JS Divergence. JS Divergence. What is JS Divergence? So this is on the name of again two scientists, Jensen and Shannon. Jensen and Shannon divergence. So this is nothing. Jensen JS divergence is nothing but an increment, a simple increment over KL divergence, which addresses some of the drawbacks of KL divergence. This Jensen and Shannon makes it symmetric. So this is a symmetric, solves this. This symmetric implies DKL JS. This is JS. The JS of PQ is equal to DJS of QP. This is how we write divergence. So this is symmetric. So it solves this. And this also okay. This is always finite. This also solves one more thing. This is always finite. Why so? Because if you see the formula of KL divergence, there is Px by Qx. So saying some condition probability of an event is 0. This is not equal to 0, and this is 0. If this is not equal to 0, this will be 0. This probability will become infinite, right? Because log of infinity will be infinity because it is a monotonic. So this term will become infinite. So the whole divergence will become infinite. So Jensen and Shannon divergence, it also solves this. It makes it finite. How does it do it? We'll see the formula and then it will become pretty obvious. So this is also always finite. It solves one more problem. It makes it symmetric. Plus, it solves that problem for KL divergence and it makes it finite. So these are the two things it addresses. And how is it defined? So this is the average distance between KL divergence of two distributions and their mixture. So this is the average distance between KL divergence of two distributions P and Q and their mixture. So let's define it. So dJs of P and Q is equal to average distance. This is average distance of KL divergence. So half dKL of P given M plus half of average KL divergence. This is just an increment over KL divergence. Q given M. This is the average of the KL divergence of two distributions with respect to a mixture. And what is this mixture? How do we define this mixture? This mixture is half of P plus Q. This is the midway. This is half of P plus Q. So this is the average here, and this is half of P plus Q. So this will solve both that symmetrical problem plus that will make it finite, because we are measuring it against a average model which will not become 0. This is average of these two. So if any one of them is non-zero, so this M term will not become 0. P is not 0, means the average will not become 0. So this will never become 0. The denominator will not become 0. Here M will not become 0. So this will not go to infinite. And also you will see this, that both the sides, it is half of the average. So this will be symmetrical if you do both the sides. Either you do this way or that way. Okay, so that's kind of self-explanatory. Let's do a simple problem, the same cat and dog problem, to understand this. For example, that cat and dog problem that we are discussing. So what is the truth? The probability is that this is with 1 probability cat and this is with 0 probability. So this is our truth, that there is a model which is trained to classify images, of cats and dogs. And the truth is, I have a label that of one image that it is 100% cat and 0% dog is the truth, and I have labeled it. So the probability of it being a cat is 1, and probability of it being a dog is 0. So this is how my base is. And let's find the Jensen and Shannon divergence for this, the JS divergence. So this is a true label. So first of all, how do we go? Let's go step by step. So step 1. What is my step 1? That calculate the average first. So this is my average. So let's calculate the M first. So M is equal to half of P plus Q. Okay, and let's define. So let me talk of QA. The first model A is that it tells that 0.8 probability cat, and this is dog. So this is cat and this is dog. So what will be the average of this? M will be equal to, this was P was 1 and 0, so this will be 1 plus 0.8 by 2 comma 0 plus 0.2 by 2. So this is equal to 0.9 comma 0.1. This is my M. So this second part is solved. Step 1, we go this, and then we'll calculate this term and take an average of this. Okay, step 2 calculate this, step 3 calculate this, and step 4 take an average, we'll get it. So step 1 we got the M. Step 2, okay, let's calculate the KL divergence of M and P. So let's calculate calculate, let me write it down for you. DKL of P and M, this is equal to sigma, again sigma summation all of them. Okay, probability of X log of probability of X by M of X. This is how it is defined. So this is equal to, what are all the possibilities? There are only 2 possibilities, so we'll check that. So this is first is probability of getting a label 1, so that is coming from the actual distribution, so that is coming from P of X. So P of X is 1 into log of Px by Qx. Log of Px is 1 and log of Mx is 0.9 plus, everything is plus here. Okay, and the second term is 0. Actual, this is for cat and this is for dog. So actual probability of it being a dog is 0 into whatever the term is, but I'll write it down. So this is log of 0 by 0.1. Again, you see this is 0 log 0, this is undefined. So for computational purposes, we'll take it to be defined. We'll take a hack to make it 0. So what will this first term be equal to? This is 1 will be 1. So this is log of 1 by 0.9. Everything is base 2. This is equal to, let's calculate this quickly. Log of base 2 1 by 0.9 is equal to 0.152. This is equal to 0.152 bits. This is your DKL of P and M. Step 3, the other part, DKL of Q and M. So this will be again summation of Px. Okay, Qx log of Qx by Mx, summation of this. So what is my probability of Q? What I have defined, whatever A is here, 0.8 and 0.2. Let's solve this. So Qx is now 0.8 into 0.8 by Mx is 0.9. We took the average, right? M is 0.9. This was 1 and 0.8. Its average is 0.9. So 0.0 and 0.2. Its average is 0.1. So Qx, that is the actual, and I am predicting it using the average model. So 0.8 by 0.9 plus, this will be 0.2, the dog probability, into log of 0.2 by 0.1. This will be, so this is equal to, this is 0.2, 0.2, and this is all base 2. So this become 0.2 by 2, this will become 2. So log 2 base 2, this will become 1. So this is equal to 0.8 into plus 0.2 into 1. So what is log of base 2, 0.8 by 0.9? So So log of base 2, and instead of 1, now the second model predicted as 0.8. So this is minus 0.169. So this is minus 0.169. Okay, 99. So let me take it as minus 0.17. That will be easier. And now I will do it as 0.17 into 0.17 into 0.8. So it becomes 0.136. So this is equal to minus 0.136 plus 0.2. This will be equal to 0.064. Okay, so dKl of m is equal to 0.064. So final step 4, let's calculate JS divergence. So this is equal to dJs P of Q is equal to half of dKl P and M plus half of dKl Q and M. Okay, this is half of 0.152 plus 0.064. This is coming from here, 0.152, and this is 0.064, and this is equal to half. This will become finally half into 0.216. This is equal to 0.108. dJs P and Q is equal to 0.108. Okay, so this is, if you see the Jensen's JS divergence for your first case. How much was the KL divergence? Let's check. For the first case, this was 0.32 bits, and in JS divergence this is 0.108. it is less. Okay, so the lower the value means the closer are the two models. Okay, and if both the models become same thing with the case of KL divergence also. Say for example, what is the formula here? This is P and Q. So if both the models become same, Px and Qx will become same, so the KL divergence will become 0. Okay, I just want to remember. Okay.